Absolutely. Good morning. My name is Rick Ashford. I am a systems engineer with SUSE. I am based out of Round Rock, Texas, so right around the corner from Dell itself. And my job is to work with the sales teams from a technical perspective and help them out in any way they need in order to make the sales. We have with us also on the line Doug Jarvis, who is the product manager for SUSE Cloud. Excuse me, product marketing manager for SUSE Cloud. Sorry, Doug, I didn't want to give you a promotion there, or demotion, depending on how you look at it. And then we also have Nathan Barney, who is one of our marketing people. Excuse me, who is our marketing person in charge of the relationships with the hardware vendors. So. What we'd like to talk today about, as was said in the introduction, is a little bit about SUSE Cloud and our relationship with Dell and how we are going to be going to market on that, and then show you what the product looks like. So just real quick, talk a little bit about why SUSE Cloud itself. SUSE has been around for 20 years. We are actually the oldest commercial Linux distribution that's out there. We're the first enterprise distribution. Linux itself has only been around for 21 years. So at this point, we were very close to the inception of Linux. And over those years, we've developed a world-class support organization. Linux is fantastic, but the joke goes that Linux is free as long as your time is worth nothing to you. It does chew up time. It does chew up resources, and that's why there are commercial Linux vendors like ourselves out there to be able to do all those pieces that need to be done and make it so that it's very rapidly deployable and easily usable by yourself. And so what you are paying for when you pay for Linux is for that expertise and for that knowledge and that support ecosystem. Part of what we're doing in order to make SUSE Cloud more deployable is simplifying the installation and the operations, and that means that we are providing an installation framework for installing SUSE Cloud, and that is done through an open source project called Crowbar. And this is actually the beginnings of our working with Dell. Crowbar is a project that was originally begun by Dell for the purposes of doing bare metal installations of OpenStack. And when we were evaluating solutions for setting up SUSE Cloud, we felt like Crowbar best fit the needs of our enterprise customers. And the nice thing about using SUSE Linux is that you get a Tier 1 operating system that is supported on a wide variety of different hardware platforms. We preserve all the APIs that are part of the OpenStack solution, the open source OpenStack solution, so that any third-party tools that you have that you are interested in integrating into OpenStack will be able to integrate with that. And then we're also complemented by a couple of powerful solutions, which we're actually going to show today as part of the demo. SUSE Studio is a tool for creating images to be able to deploy out into the cloud or onto a wide variety of different platforms. And then SUSE Manager is a tool for being able to manage your Linux instances after they're deployed. And I'd also like to point out that we're really excited to be working with Dell and going to market on cloud. We feel like Dell brings some fantastic expertise around hardware, around enterprise life cycles, and we're really looking forward to working with them and helping you develop your cloud solutions and simplifying life for everybody. So what we're going to be showing in the demo today is we're going to be showing SUSE Studio to begin with, and we're just basically going to walk through the life cycle of a workload, where we're going to actually create the image, put it into the cloud, launch it up, and then go through and be able to manage it and do the different things that you need to be able to do. It's really exciting stuff that I think that we can do, and we'd like to ask you, consider doing a proof of concept. We'd love to be able to sit down and talk with you, get a couple days. It can be in your facility, or we can do it remotely, whatever makes the most sense for you, and we can discuss, giving this a kick in the tires and seeing if this actually works in your particular environment, and getting you what you need. So, with that, we're going to go ahead and jump into demo time. All right. So what we're looking at right now is this is the login page for SUSE Studio. SUSE Studio, as I said, is an image creation tool. Typically, in an enterprise workload, if you're dealing with Linux images, with traditional Linux image creation tools, the image creation process is a little bit cumbersome, and as a result, typically what people will do is they will simply create one version of a disk image for, say, their physical systems, another one for their virtual systems and whatnot, and they'll just have a plain OS. And then whenever they need to launch it, they'll launch it up, and then at that point they will go in after it's been instantiated, and they will add in applications and configuration and all that kind of stuff to make it usable for them. What Studio does is it simplifies the image process such that you can actually do all that work in terms of installing applications and configuration ahead of time and bake that into the image itself, so that you have an image that is pre-cooked and ready to go for your particular application that you're going to do. So there's a couple different ways that you can create a new appliance in SUSE Studio, or a software appliance, or a new workload. You can come in here to, we've got some base templates. So this just enough operating system, or JUICE, is literally just barely enough operating system to be able to boot. So in and of itself, it's not terribly useful. But what it does do is provides a very nice foundation that you can then simply layer on the pieces that you need for your particular application. This is very nice if you are, excuse me. This is very nice if you are in an audited type environment and you need to have some sort of compliance. It makes it real easy for security people as well, because they don't have to worry about certain ports being turned on or services being exposed if they never get put onto the appliance in the first place. You can simplify it down so it only has the pieces that you need for your particular appliance or your workload. So the other way that you can do this is if you have pre-built workloads already ready to go, you can go ahead and configure it up with, say, all your configurations for authenticating against your Active Directory infrastructure, or all of your security policies around application access and all those kind of things. You can bake some of that stuff in ahead of time and have kind of a base template right here, and then just simply clone off of that to create a new system. So that's what actually we're going to do right here, is we're going to clone this, and we're going to call, because I am super creative, we are going to call this the webinar server, and prepare this up to be able to be used. So some of the information that's showing up on here, if you look up here in the corner, the 160 megabytes download. So by default, we've got this in a QCOW2 image, which is used in KVM. And QCOW2 has compression built into that particular disk format. So as a result, it's a fairly small download size. You can also see that it's 490 megabytes uncompressed. That's the bare minimum amount of disk space you need to have. This is actually one of the really neat features about Studio. Typically with Linux image creation tools, there's a 1-to-1 ratio between the size of the disk that you're targeting and the size of your disk image. So that means that if you're going to be building for a 10 gig disk image, 10 gig disk, you need to have a 10 gig image. Or if you're going to be building for a 20 gig disk, you have to have a 20 gig image. You can see that very quickly that does not scale very well. Even if you're just looking at that 20 gig image, if you've got that in your image repository and you have 100 people that request it simultaneously, transferring 20 gigs 100 times across your network simultaneously is not going to be a fun experience for anybody. So what Studio does is it builds the appliance, the workload, so it's just barely big enough to hold whatever data you have inside of it. And then it will simply, on the first boot, it will detect the amount of available local storage and expand out to fill that space. That means you can have a much smaller disk image. I mean, 160 megabytes is much easier to work with than 10 gigs or 20 gigs. And passing that across your network. So that's a really nice piece of it. Moving right along though, under the software sources, you can see right here I've got the standard SUSE Linux repositories. I have the ability to add additional repositories if I have my own custom ones sitting in my data center someplace. I can add in those repositories and make those those packages be available. Or if I just have individual RPM packages that I want to upload into the appliance, I can click the button and upload those right here. Moving down a little bit, you can see you have the ability to search for software. So, for example, if I wanted to make a port scanning appliance, I could find the Nmap package. I can look at it. You can see that there's a clear text description of what that package is and does. I've been working with Linux for about 14 or 15 years at this point. And there are tens of thousands of packages that are out there. Even after 14 to 15 years, I don't know 100% of what every single package does. So it's very nice to be able to see what these do. You can also see the license that is required by that particular package, and be able to work with it that way. Another thing that's worth pointing out right here is we have what are called patterns. Patterns are a collection of one or more packages that together provide a specific service. So, for example, we have patterns for doing an Oracle server. So, if anybody here has ever had the joy, and I use that term loosely, of doing an Oracle installation on Linux, you know that the quick start guide for that is something about 25 to 30 pages long. It's not a quick and easy process. What this does is this pattern will actually do all that work for you, so that it'll install all the dependencies, it will do all the kernel tweaks and the user account creation, all that kind of stuff, so that you can just simply install your Oracle media and move into the actual installation process. So it will simplify that process for you dramatically. Another one that's available in here is we have a LAMP server, so the standard Linux, Apache, MySQL, PHP/Perl/Python web stack. You can see that is available in here. By default, it's just the Apache web server. However, if you want, you can add in additional software to flesh out the image. So let's go ahead and make this a web server. We're going to go ahead and add in the LAMP server to our system. And let's go ahead and start configuring it up. All right, so under configuration, we can start off. We can set our time zone, our locale, our network. If we want to have a firewall enabled, we can do that. And then if we're going to do local-based authentication, we can set up our users and passwords over here. Even if you're going to be authenticating against, say, an Active Directory, you'd still want to be able to come up and set your root password so that you can get in the terminal if there's no network connection. Moving right along, this is actually fairly popular. This is a cute little feature where you can upload logos or images and use these and create custom boot splash screens for whenever the system boots. This can be your company logo. If you have a webcam and you want to take a picture of yourself and upload it, you can do that as well. And then that's what you'll see when the system is booting up. Fun stuff. So moving right along, you can indicate whether you want to go to a console or to a graphical login when you boot up. You can add an end-user license agreement if you want somebody to have to acknowledge that they're going to follow all of IT's policies and not do such and such, and make sure that they bring donuts every third Wednesday, something like that. You can add that into the EULA section right here, and then they have to acknowledge that every single time that they launch a new instance of this particular workload. If you add in MySQL or Postgres, you can actually upload a dump file and set up the users such that you can have the database prepared and ready to go, so that as soon as you launch it up, it's actually ready to start serving out data for you and be useful. You can see the little red message over here is indicating that I'm going to set up MySQL, but I haven't actually installed the package, so we're just going to go ahead and drop out that check mark and pull that away. All right, so Under the appliance section right here, we can start setting things like memory allocations and disk size and swap partitions. We can indicate whether we want to use logical volume management for our disks. We can tell we want to integrate with SUSE Cloud. What this integration does is enables you to do automatic SSH key pair injection so that you can do passwordless login to your systems. And then we can integrate with SUSE Manager, which is our management tool. You can see I've already got that set up for you so that it can be managed and taken care of and maintained as soon as you launch it up. As soon as you launch up a new instance of this particular system, you can run scripts, and you can run a script either at the end of the build process, or you can run it whenever the appliance boots. That can be the first time it boots, or that can be every single time it boots. It just depends on where you put your logic in the script. It's very flexible, and it gives you a lot of granular control over how you want to have things configured on your workload. Now, I mentioned before that you could upload your configurations for, say, your security policies or your authentication against your LDAP directory or whatnot. This is where you would do that. You can upload a zip file. You can upload a text file. And you can add that to the appliance. It's worth noting that if you have a tarball or zip file based application, you can actually upload that compressed file directly. And we are going to be talking about OpenStack. This is moving into creating the image for OpenStack. It's just moving right along. Good question though. Thank you for asking. So you can create the file, put it in here. And it will, you can extract it out to whatever place in the system that you want it to be, and have that application available to you. Okay, so now into the actually building it for OpenStack right here. So this is the build targets. We're going to go ahead and start this process right here while I'm talking in the background. You can see by default we're going to build it for SUSE Cloud /OpenStack /KVM. This is the QCOW2 image. But you can see there's a number of different ways that you can build this particular image, and then you can have a consistent format and build across all these different platforms that you have right here. So while this is building, we're going to go ahead and move over into the actual cloud section. Well, I guess I should say first off, we do have an integration set up between SUSE Studio and the cloud, and basically what happens is that whenever Studio finishes making a build, it will actually send a message over to the cloud server saying that there's a new build available. I've got a service that's sitting over there that's listening, and it will automatically import this appliance that we've created, this web server, directly into the cloud environment, and it'll be ready to deploy. So as soon as this gets finished, it will show up on the other side. We're going to go ahead and move now over into the OpenStack dashboard right here. And this is when you first log in as a user, you'll have a quick overview of what instances you have up, how long they've been up and running, and how much of your resources you are using. We're going to start off by walking through some of the things you have in access and security. So floating IPs, essentially what happens is that when you provision a new workload on OpenStack, it will provision out on a network that is intended to be used for communication internally within the cloud. If you want to be able to expose that workload out to an external LAN or to the internet or whatever, you need to have some floating IP addresses that you can assign to those workloads to be able to share them out. So in this case, I've got two floating IPs that I've set up. You can see one of them has already been assigned to a workload that I've already got running. You can set up security groups. So by default, you can see that this is essentially a firewall for the entire cloud. By default, it blocks all port traffic and communication. So if we wanted to open things up, you can do, for example, if I wanted to set up and allow SSH traffic for all of my instances, I could simply do this and add in the rule. Let's go ahead and do that. Ta-da! So we've got our port SSH. If we wanted, for example, to be able to ping, we can open up ICMP traffic. added in very quickly and easily. You can see that you have the ability to do this to a global range, or you can do this to a smaller subnet, or you can just do it on a host by host basis. All right. Under key pairs, you have the ability to either create your own key pair or to import an existing one that you have. And again, this will enable you to do the passwordless authentication across to your instances when you launch them. All right. So under images and snapshots, and real quick, let's check and see if our server is up. It should be coming across soon. There we go. Right on time. So you can see right here we've got our webinar server that we just built. It's automatically appeared here in the cloud. It's a pre-configured web server that if we gone through and added in, our application, all that kind of stuff, it could be literally ready to just launch up and be a blog or whatever it is that we want it to be immediately upon launch. So let's go ahead and launch it and do something with it. We're going to call this, because I'm still creative, we're going to call this webinar. Again, you can select the size of the image, size of the host that you want it to, the virtual machine that you want it to launch on. In this case, we're doing this all off of my laptop, and so we're going to keep this as small as possible so that we don't overpower stuff. So we've gone ahead and we've launched our new webinar image. So let's go ahead and give it an external IP address so that we can see it outside of the cloud. All right. And you can see, here we go, we're up and going. And you can come in here, you can see some additional information about it. The nice part is you can actually see the console of the cloud right here. You get the VNC when it comes up. And it's being difficult on the VNC, so we'll go ahead and pass that by for right now. But it'll have the VNC. You can actually pull up and watch the terminal boot up and watch it go through all of its different actions as it's coming up. So you can see right here we've got different projects. So a project is essentially a collection of resources. It's a logical container for different instances in the cloud, and you can add the users to it and whatnot. In this case, I'm the admin user, and this is my personal project. You could have projects that are set aside for, say, the HR department, for the finance department, for any number of places. And it really is that quick and easy to go in and create systems and launch them up. So the third part of what we wanted to show today is a tool called SUSE Manager, which gives you the ability, after you log in, after you create these appliances, they'll go through and automatically register themselves against SUSE Manager, so that you can then do things like patch management and whatnot. And this is important to the overall cloud ecosystem for one very key reason: compliance. It was interesting, at the OpenStack Summit in Portland back in April, we actually presented and showed this whole workflow at the summit, and we had somebody come up to us really excited afterwards because he was a compliance officer, and he said that studies that they had gone through had shown that roughly 100% of all workloads that were running in the cloud were doing so unpatched. That means it was less than 0.5% of the workloads that were running in the cloud were patched. That exposes workloads to all sorts of different vulnerabilities and issues. SUSE Manager gives you that vision into what your systems are doing and what they are, so that you can go in and take care of them. So while we're waiting for the instance we created, our webinar one, to register itself, it takes it a couple minutes. I've got this other one called Base that I launched up this morning, and it has already come through. We can see right here right away. This has quite a few patches that are available for it. So I can click on this particular system, come over here to the software, say, hey, let's go ahead and upgrade this. You can see all the different patches that are available for this particular system. you'll notice there are a couple different couple different little icons over here. The little picture of a bug is a bug fix. The little red shields, those are security patches, and somewhere in here we'll have some that have little green boxes on it, and those are excuse me. Those little green boxes are feature enhancements. So let's go ahead and take a look at this kernel patch, for example. Actually, let's grab this guy right here. So we can look actually at the security advisory in here. We can see the full text description of what that advisory is, with links back to MITRE.org for the CVEs. You can see that this one addresses some issues with Btrfs file system. You can see all the Bugzilla entries that are associated with this particular patch. This is a large one. And then you can see that it indicates that you're going to need to reboot after you install this patch, and SUSE Manager can actually detect that, and it keeps an ad hoc group together of all the systems that need to be rebooted based off of this. You can see we've got the links again to the CVEs. You can see all the information you need about this particular patch. The other nice thing is you can come over here and see what the affected systems are by this particular patch. So if, for example, you have somebody in management who is asking you what is our exposure to this particular CVE, I read about it in a magazine or whatever, you can come over here and see, okay, I've got 2 systems that are impacted by this, and we can patch it right now, and life will move on, and life will be glorious and grand. All right. So at this point, we can talk a little bit more about SUSE Manager and some of the pieces that are in here. Basically, this gives you the ability to do that patch management. You can do configuration file management where you're enforcing particular configurations on the systems. You do have the ability to do a couple of neat things. So, for example, we can come over here to profiles, and we can create a system profile, for example, of what packages are installed on a system at a given point in time, and then we can compare that system. So say we create a snapshot right after we get something working, and then after a series of patches, it stops working. You can come back and compare the profile, and it'll show you exactly which packages have been added or have been updated since then, and you have the option to actually roll it back to the state that it was in when it was working. The other thing you can do is you can take 2 systems. So say, for example, I've got this base one right here, and I wanted to compare it up against this other one. We can run the comparison, and we can actually see what the differences are between the 2 systems. So if you had, say, 2 systems, one's working, one's not, you want to see what's different between them, you can show it up right here, and then you can tell it to sync the packages over so that your system, you can make the one that's not working look like the one that is. A couple other neat things you can do. You can do service pack migrations. So, for example, if I've got a system here that's on a previous service pack, I can actually come over to the service pack migration and schedule that up and set it to migrate your system. So, a bunch of neat things that you can do. It does have monitoring included as an option in here if you want to be able to do system monitoring. Many people have their own tools already in place for doing that, so we don't necessarily have to have that as part of your SUSE Manager implementation. So what we've done here then is we've shown the entire life cycle of moving from creating an image that's going to be used in our cloud, and you can see that the image creation process is very quick and easy to be able to get something that's usable. It automatically synced across here to our cloud environment, so we can launch it up very quickly and easily, get access to the system as we need it, and then once it's launched up, it'll appear here in our SUSE Manager, where we can apply all the patches and do that post-launch maintenance that needs to happen in an enterprise class data center. So this is the solution that we are bringing to market jointly with Dell. I'm happy to take some questions at this point.
All right, so feel free to post your question in the chat window. you have any? And if you haven't, Doug, maybe can you tell us what customers, what are the questions that they're asking around SUSE Cloud? Oh, we have one question. Can I manage other instances other than SUSE with this tool, via window deployments, for example?
So SUSE Studio, the image creation tool, is only for creating SUSE appliances. Inside of Cloud, you can launch whatever workload you want. So that can be, another Linux distribution. You can launch Windows inside of there. You can launch whatever you want inside of SUSE Cloud. SUSE Manager will manage any RPM-based Linux distribution, or I should say, any RPM-based enterprise Linux distribution. So ourselves and our primary competitor, you can manage both of those from inside of there. In fact, we actually have a program inside of SUSE where we can support Red Hat systems and provide patches and updates for it. So you can see right here, these are actually the Red Hat patches that we create ourselves and distribute, and those are available right here in addition to the SUSE Linux. So you can actually have in here, I have a Red Hat system that sits alongside my SUSE ones, and I can manage them all from the single pane of glass right here. And actually, one other neat thing that's available here is that through the API sets, we've actually got somebody on the Microsoft side who wrote a plugin for System Center that can leverage SUSE Manager and give you the ability to manage your Linux systems in addition to your Windows systems inside of System Center.
Okay, we have two other questions. First one from Praveen. How and when are the appliances configured to talk to SUSE Manager?
So if you come into the appliance section right here under configuration, under appliance, you can set right here. You can integrate with SUSE Manager. You tell it the URL, and then you tell it what Bootstrap script you're going to do. I, for example, have a specific Bootstrap for my private cloud guests, and what that will do is it'll automatically add it into my cloud guests group and make it part of my infrastructure.
All right, we have. Sorry. Okay, go ahead.
There was another question about.
Yes, we have two more questions from Magnus. Do you support Novel OS and SUSE Manager?
Yes, we do.
Okay. How does Crowbar? Okay, go ahead.
No, that's fairly recent, but that, to my understanding, that work is done now.
Okay. And how does Crowbar integrate with SUSE Cloud?
Right, so Crowbar is actually an integral part of SUSE Cloud. We were showing just the user experience right here, but we could actually go into the Crowbar node itself. Oh, whoops. If I use the right URL. And Crowbar is the deployment tool that we are using for doing the bare metal installation and setup of the systems. So we didn't really go into this in the demo. We can talk about it for a moment here. For those of you who are not familiar with Crowbar, essentially what you do is you take your systems and you network boot them against the Crowbar server. When you do that, they will show up here in the list. You can see that there's some discovery work that goes on to identify the machine, and then you have the ability to do what's called an allocation, where you can allocate the system, and what that means is that it'll install an operating system on there for you, and then once it finishes the operating system install, you can actually go and apply what are called bar clamps. Bar clamps are plugins for Crowbar that will assign a particular role to that system. In this case, you can see I've got most of my bar clamps applied. I'm not doing the large huge scale object stores that Swift or Ceph can provide for you, just because it's out of the scope of this particular demo. But you simply come in here and create a bar clamp. It will assign it to a server by system by default, and then you just click the apply button, and it will go through and configure up the system to install it and set it up for you. My joke is that if you've got your Crowbar server set up, if you can operate a power button and you can operate a mouse, you can install your OpenStack in a very quick fashion. So thank you for the question about Crowbar. So certainly. So SUSE Cloud is our commercial offering of a private cloud infrastructure. It is based on OpenStack, as you can see by the nice little logo up here in the corner. It is basically our combination of the OpenStack project with Crowbar, which is the tool we're in right now for being able to do the bare metal deployments, and then combining that together with our support ecosystem and our engineering excellence, and providing a a solid base for deploying your cloud on. We are actually currently the only enterprise class Linux operating system that has an OpenStack based solution out in the market right now. Certainly. Certainly. So the big differentiator for Crowbar is that OpenStack itself is exceedingly difficult to get up and get running. Um, we've actually got a slide that we show sometimes that has a couple of numbers that it throws up there. The first one is 782. And 782 represents the number of configuration options in the S6 release of OpenStack that you have to configure in order to get everything set up correctly. With 782 options, there are so many different ways you can shoot yourself in the foot. It's not even funny. The next one is 11. The number 11 represents the actual number of projects that make up OpenStack. OpenStack itself is more of an aggregation of several different projects altogether. There are 11 of them and growing. So you're not just doing one product install, you're actually doing multiple product installs simultaneously. And then the next the number that was on the slide that was put together by our product manager, I'm not sure that I believe this, but the survey results said that people were saying that it took them at least 2 days to get OpenStack up and running. And quite frankly, aside from a developer doing it on their laptop, I haven't talked to anybody that managed to get it up and running in 2 days. Usually it's 2 weeks is about the best I've heard of, but I've heard people saying that they've been working on it for 6 months to a year, and it's still not working the way that we want to do. So there's a lot of complexity in OpenStack. So what Crowbar does is abstracts away a lot of that decision-making process and only presents you with a few things to be able to decide. So for example, if we come in here to the Nova project, so of those 782 configuration options, 467 of those are for the Nova project, which is the actual compute engine that enables the scheduling out of the workloads onto the targets. So you can see right here that the proposal for Crowbar, for Nova, it has things that you can select inside of here, and it has a couple choices you can make in terms of what hypervisor you want to do, in terms of enabling high availability. Do we want to allow say network traffic? But the nice thing is that it will not. It's abstracted away a lot of that complexity. So this is actually significantly less than 467. A lot of those decisions are made for you through Crowbar to simplify the process for you. If you have your Crowbar server set up, you can literally deploy a cloud in as little as half an hour.
Outside of just deploying OpenStack,
if you have more
what are some of the other key features? I saw you had some of the services there listed, actually right there. What are some of the services there? What do some of those things do, and what's that?
You'll still spend a fair amount of time in the planning phases to get yourself ready to actually deploy. But in terms of actual deployment, Crowbar makes it very quick and easy to deploy a new system, to deploy the system. All right, fantastic. Any other questions? Certainly. Great question. Thank you. So you can see right here that there are a number of different services. As I mentioned earlier, there's a number of different services that make up OpenStack. So you're going to need a backend database for your system. The default for most OpenStack installations is MySQL. In our particular case, we're actually electing to go with Postgres for our backend database. Keystone is the authentication framework as part of OpenStack. It provides the authentication for the users to be able to log into their particular projects and get access to their resources. Keystone can be a local-based authentication, or it can be back-ended by an LDAP database such as OpenLDAP or even Active Directory to get you that authentication. I'll get back to Swift and Ceph in just a second. We'll skip on to the ones that are actually deployed right here. So Glance is an image repository. So when we create that image in SUSE Studio and it kind of shoots across, what's actually happening is that it's, as I mentioned, Studio sends a message over to a service sitting on the Glance server that says, hey, there's a new build in here, and that service will simply pull in that and import it into the Glance repository. Once it's into Glance, that makes it available under your list of images for you to be able to check out and deploy to your systems in your cloud. Nova is the actual compute engine. It's actually it and Swift are the two original projects that made up OpenStack. It was originally written by NASA. It is the compute engine behind everything. So essentially, Nova is what decides what workloads go onto which systems and what systems are up and down and coordinating all that information. That is done through the Nova project. And then Nova Dashboard is quite simply the dashboard that we use to be able to come in here and actually interact with the system. One of the neat things about the dashboard actually is the dashboard doesn't make any direct calls into OpenStack. Everything is done through APIs that are exposed to you. So anything that you saw me do here on the demonstration can also be done on the command line in a scripted fashion if you like. In fact, there's more functionality that's available on the command line than what is exposed here in the dashboard. So, getting on to Swift and Ceph, there's actually three types of storage that make up OpenStack. There's what's called ephemeral storage or transient storage. There's block storage, and then there's what's called object stores. So to show you what the difference is between those, if we come over here to our actual instances, you'll notice down here I have a volume right here, and I've got my instances. The instances, by default, run on what's called ephemeral storage. What that means is, ephemeral means it can go away. It's transient. So if I decide to come over here and terminate, for example, my webinar instance or my base instance, click the terminate button, that storage right there goes away completely. It's lost and it never comes back. If you want to have some sort of persistent storage, in case you need to launch up, say, a new version of a particular workload or whatever, you would put that permanent storage onto the block storage here in the volumes. So you can create different ones. So let's go ahead and create, for example, we'll call this webinar again, and we'll give you 1 gig of block storage. We'll create it out, and then we can just simply attach it to our webinar, and then we've got block storage that's attached to there. That's really nice because say you have a new version of Webinar that has been created. You notice we've got this external IP address, this 122.130 that we've assigned here. If we bring up a new version of Webinar, when you build it in Studio and it comes across, and we launch the new instance, we can simply detach the storage from the original Webinar, and then attach it to the new version, and then take the floating IP address and migrate that over to the new version as well. It makes for a very clean and easy process to be able to migrate systems to new instances. So that is the ephemeral storage and the block storage. And the block storage, by the way, can be backended by a number of different things. It can be just a simple local disk on the compute nodes. It can be backed up by a SAN. In the case of Ceph, there's actually an option for it to be backended by the Ceph object store. There's a couple different ways that you can do that. It's pretty flexible in terms of where you get this storage from. So, coming over here to Swift and Ceph, these are what are called object store. So for the purposes of comparison, for those of you who are familiar with Amazon's S3 service, this is the same concept as Amazon S3. It's instead of being like a traditional file system where you interact with files and do your manipulations directly, an object store, you check out objects from the store and you cache them locally, you manipulate them locally, and then you check them back into that object store. So Swift is the object store that was one of the original projects in OpenStack. Actually, OpenStack itself was founded 3 years ago when an engineer from NASA and an engineer from Rackspace, who were working on Nova and Swift respectively, talked together at a conference and realized that their projects had synergy, and they came together and created a cloud platform. So Swift gives you that object store to be able to have massively scalable, and this is the neat thing about Swift and also Ceph, is that these things are designed to scale out to tens of thousands of nodes. It's designed to scale out just huge numbers of nodes, and it also changes the paradigm of the way you treat servers. There's the whole pets versus cattle analogy, wherein a pet is something that you give it a name, you care for it. If it gets sick, you take it to the vet, you feed it, you take good care of it, right? Whereas cattle, if cattle get sick, you just take it behind the woodshed and you shoot it. And so traditional IT has been very much a pet type environment where you keep those systems up and running and you nurse them and you do everything you can to keep them nice and warm and comfy. Actually, nice and cool and comfy. I guess you don't want them too warm. But you take care of them. What cloud computing does is really gets you into the concept of, hey, if I'm working with tens of thousands of nodes, even if I only have a 1% failure rate, I'm still going to have lots of systems failing all over the place. So I need to be able to acknowledge that and be able to deal with that as part of the overall system. So Swift gives you Swift and Ceph gives you the ability to have that object store and be able to expand it out over multiple nodes. You can tolerate a failure on any number of nodes simultaneously, and it will go on. I mean, you can literally take a shotgun or a baseball bat to an individual server, and these systems won't care. So Ceph is the new kid on the block. So as I said, Swift was the original. It's very deeply integrated into OpenStack. Ceph is the new kid on the block. They're just a year or so old. A little over a year. But it's an object store similar to Swift, but it has a number of different features that are really exciting about it. The downside to Ceph as compared to Swift is that Ceph is not as deeply integrated yet as Swift is into the OpenStack framework, but it does provide some really interesting things that Swift does not do. So, for example, Ceph has an algorithm that it uses called Crush that determines where it's going to stripe your data, and so it handles all the data striping, the mirroring, the pooling, all that kind of stuff automatically for you in the background. And it will do things like, say, if your data is something that's very popular, it will replicate it more times throughout the cluster, so that it's available as a local file to more systems. If it finds that this particular data is only being accessed by this little corner of the data center over here, then it will actually migrate that data over to that corner of the data center. So again, it can be more localized access to that particular system. It will do all this management in the background of your data to try to optimize your access. The other thing that's neat about Ceph is there's a much more robust suite of methods for being able to interact with it. So Swift, basically you have the API that you can use to check objects out and in, and that's pretty much it. With Ceph, you've got several different ways you can do it. There is the ability to do the API, just like with Swift. And by the way, both of those implement the Amazon S3 APIs as of this minute. They both implement that Amazon API. So if you have an S3 system that you wanted to migrate onto here, your existing scripts should work. But the other thing beyond that API, Ceph also provides there's a library there's libraries for C, C++, Java, PHP, Perl, Python, all these different things to give you programmatic access to it. There's also what's called Rados Block Device Driver, or RBD, which enables you to take that object store and present it out as a block device to the systems. If you remember when I was talking about the volume storage a couple minutes ago with OpenStack and how you could potentially back in that by Ceph, that's how you would do it. Is you can use that Rados Block Device Driver and present that huge object store as a block device to your instance, and you get back ended by this huge unlimited data store that you've got back behind it. In addition, they're also in development on a POSIX compliant file system that could be on top of the object store, so that you could just simply mount up the file system and then be able to interact with it just like you would on any normal standard file system. And obviously that opens up all sorts of neat little doors for being able to do fun stuff. That file system is not stable yet. It's not ready for production, but it's getting there. So that, in a nutshell, is the different storage mechanisms for the cloud. So, any other questions? All right, I think we're good. Oh, hold on. I do have. We do have a couple of things we can share. No, we're done. So I'll see the question in just a second. I can't see it at the moment. Just want to talk real quick about the roadmap. So our 1.0 version of SUSE Cloud is based off of the Essex release of SUSE Cloud. Excuse me, Essex release of OpenStack. Our 2.0 actually went into beta yesterday, and it is based off of the Grizzly codebase, which is the current codebase. Our 1.0 uses Zen and KVM as your hypervisors. With 2.0, we're going to be adding Hyper-V, and we're going to try to get some form of the VMware support inside of the product. There's a couple of issues that have to be resolved in there in terms of code quality and various other things that have to be resolved before we can have the VMware support in there. But that is something we are trying to have some level of support for VMware inside of there. And then we're looking at a release date of our 2.0 cloud roughly in the September timeframe. And then we are planning to have a Havana-based release in the first quarter of 2014. And you can see we're looking at adding things like Ceilometer and Heat and a couple other things into there, and some high availability pieces that we're looking to incorporate into the Havana release.